Hey guys, so in this video we're going to be talking about the applications of limits. So we're going to be focusing on velocity and the two different types. So this video is actually going to serve as a nice transition from chapter 2 to chapter 3, which focuses on from limits to derivatives. So let's get started. So here we have that limits can be used to find the blank and blank velocity. So we're really going to be discussing two different types of velocities because they actually tell us two different things, and you guys will see how. So we're going to be focusing on first the average velocity, which is actually a slope, and we'll talk about what kind of slope is it, and then the instantaneous velocity, which is kind of a new idea, and I'll tell you guys how. Although the average velocity has been a concept you guys have done before, and I'll show you guys how in a second as well. So we're going to be talking about how these velocities are actually slopes of different lines, right? So the slope of the blank line is used to find the average velocity, right? So the average velocity we're going to refer to as the secant line. So you guys see here that this right here is going to be done for the average velocity. So the average velocity is going to go with the secant line. And the instantaneous velocity is going to go with the other line here. Instantaneous velocity is going to go with the other line here, which is the tangent line. So what is the main difference between the instantaneous velocity and the average velocity? So if you guys see here, let's write instant here, just for. So the secant line actually kind of goes over a period of time, if you guys see that, right? The secant line goes from point A to point B, and you want to see what the slope of that line is from as you go from point A, which we're going to call x0, to point B, which we're just going to call x. Okay? So the idea is that you're going to see how the slope of the line is as you go from one interval of time. So for the average velocity, we actually need an interval, and that interval is going to be x0 to x, right? And to find the slope, we're just going to use this formula right here, which it's actually a fancy way of expressing the slope formula. And I'll show you guys how to use it in an example in just a second. And the next one is going to be the slope of the tangent line, right? Which actually requires you to use a limit. So this is going to be the introduction to derivatives in a very annoying way because it actually takes a lot of time to do. But the good thing is that once we get used to these problems and we just kill them, we're never going to have to use them again because we're going to learn some rules that lets us not have to use this. Alright? So we actually have to compute this right here, which if you guys recognize, this is actually the difference quotient. The difference quotient, which we have just added a limit. That's all we've really done. We've taken the difference quotient and we've added a limit. So, which we have already done some practice on difference quotient. All we're doing is applying the limit here and how to evaluate this limit, which you guys will see if you guys did enough practice on difference quotients. This part actually shouldn't be too difficult. So now let's go into our example where we get to discuss the difference between the two velocities or the two different kinds of slopes, right? So here we have that Juan is driving to Taco Bell. His position function is given by f of x equal to 4x minus x squared, right? So there's our function. Now we're going to be talking about letter A, where they ask us for the average velocity, right? So they ask us for the average velocity in the first 2 minutes of him driving. So two things. When we have average velocity, we need an interval. So our interval is going to be over the first 2 minutes of him driving. So from the first 2 minutes means you're going to start at 0 time, and then you're going to go into 2 minutes later. Okay? So now we're doing the average velocity, so we're going to go into the equation that corresponds to the average velocity, which is going to be by the way, this is written as, it comes from x0 to x, and the slope of the secant line, which is how you compute the average velocity, is going to be f of x minus f of 0, f of x0 over x minus x0. So we're just gonna put this formula together, and this is going to be a way of computing the slope, right? So this is actually the slope formula that you guys have seen, the whole y2 minus y1 over x2 minus x1, and in essence this is just the difference in y values, which is the difference in f of x's, and the difference in x values. So let's go ahead and compute that. So we're going to actually have here f of x, right? So x is actually 2, so we're going to be computing f of 2 minus f of x0, which is x of x0 is just 0, and then over x minus 2, which is just going to be 2 minus 0. So it's actually very easy. If you label everything, it's very easy to just be organized and just be like, okay, this value is with this value is with that. So now what we're going to do is we're going to compute f of 2 and f of 0 using our function here. So we're going to have, the line is crazy long, so in the first parentheses we're going to have f of 2, which we're inputting 2 into our x's. We're inputting into our x's here. So we're going to have 4 times 2 minus 2 squared. So now let's close our parentheses. And now input 0, which is going to give us 4 times 0 minus 0 squared. And then here 2 minus 0 is just 2. So let's just keep simplifying. So here we have 4 times 2, which is 8, minus 2 squared, which is 4. So 8 minus 4 is 4. Here everything has a 0 that be multiplied to it, so it's just going to be 0 over 2. So here we're just going to have 4 over 2. Okay? So now we have finished, oh, well, not 4 over 2. We're going to change this to 2. Okay? So now our answer, the average velocity over the interval from 0 to 2, we're going to say is 2, right? So I'm going to give you guys the graph of this this function. This happens to be a negative parabola, right? So I don't want you guys to worry too much about the graphing. I'm just going to give it to you. It's going to be at, is x equal to 4. You guys can compute that if you guys want. And then what you're saying is that from 0 to 2, so this being 2, the slope of this line here from 0 to 2 is equal to 2. Which makes sense, right? We just have a positive line, so the slope, or the average velocity in this case, is going to be 2. And then we're going to be discussing with the same graph what the instantaneous velocity looks like and what exactly are you finding, right? And then I'm going to give you guys a little extra work if you guys want to do on your own. So this whole instantaneous velocity and slopes and derivatives will make a little more sense. So I'm not even going to tell you guys what derivative is. I'm just going to tell you guys this is about derivatives, and in the next chapter I'll be introducing all the stuff about derivatives. So right now I just want to give you guys a little taste because it kind of gives you a head start, because the introduction to derivatives is very annoying. So this is actually going to make it a little better. So let's go into example B. See if our graph here is possible. Okay. So in example B, when we start reading, we have that we want to find the instantaneous velocity, right? And when we have instantaneous velocity, we care about the slope of the tangent, which is going to be the limit as h goes to 0 mixed with a difference quotient, which we've done before, over h. That is our formula. And then now for instantaneous velocity, we don't need an interval, right? We don't need an interval. So let's kind of write that. An interval we don't need, because it is in an instant. So we don't care about the average velocity over a period of time. We care about the velocity at that instant. All right. So we care about the line tangent to that point at that instant. All right. That is what they're asking us when they're asking us for the instantaneous velocity. So let's go ahead and write that in. So this right here is going to serve as our x, our instant, right? X equal to 1, because it tells us at the first minute, right? So at the first minute, it is just x equal to 1. So we actually lost sight of our equation, but it's 4x minus x squared if I recall. And yes, I recalled right. So let's go ahead and compute this difference quotient and then put it all together. However, if you guys remember, with the difference quotient, I like to actually compute the f of x plus h by itself, right? Because there's a lot of simplifying, there's a lot of tedious work that we have to do here. So I'd rather do it all by myself on the left hand side or by itself in a corner, and then put all the components of it together. The f of x plus h and the f of x next to each other at the end, right? It saves a lot of space. You guys can do it this way. You guys can do it all together. Up to you. I recommend you guys actually do the f of x plus h by itself and then plug it into the actual whole equation. So let's compute f of x plus h. So we're going to have 4 times x plus h. We're inputting an x plus h into every x minus x plus h squared. So now we're going to go ahead and simplify. So we have 4x plus 4h. Now, I want to take a little moment here and say that before you do this, I've seen this way too many times, where you have x plus h squared, and then you just distribute the square into both. So you say it's x squared plus h squared. Please don't do that. That is the most common mistake, and it leads to the most common wrong answers when it comes to difference quotient. So what does it mean to have x plus h squared? It means that you're going to multiply x plus h times x plus h. Alright? And yes, it's very annoying. You're going to have to FOIL. It's going to take a while. But it is the correct way of doing it, and all this work will be gone to nothing if you just mess up in that step. So, big reminder, big common mistake, avoid it. So here we have 4x plus 4h. We're going to write this a few more times because we got to simplify this FOIL thing. So now here we're going to have a minus, and I'm going to put a bracket so I can start FOILing. And I'm just going to distribute everything everywhere like that. So x times x is x squared. X times h is xh. Then h times x is another xh. And then the h's on the end multiply. So it's going to be x squared. So it's going to be another xh. And then last an h times h. So we have our multiplication there. And now we're going to keep simplifying the inside of this bracket. So it's going to be x squared. If you guys see, we have two common terms here. So it's going to be plus 2xh plus h squared. So now we're done simplifying inside of the bracket. We're going to distribute this negative. Another common mistake. A lot of people just put one negative and just don't distribute it. So it's going to be negative x squared minus 2xh minus h squared. So 4x plus 4h, and then 4x plus 4h. So now we have computed the f of x plus h. We're going to put it all into the formula. So let's go ahead and write out the formula. Let's do it in red. So once again, we don't worry about this limit all the way to the end. We just kind of like simplify everything out, and the last thing we do is actually we worry about the limit. So let's input here what we have for f of x plus h, which is 4x plus 4h minus 2xh minus h squared. So there's a lot of numbers here, so let's check. 4x plus 4h minus x squared. You see, I forgot something. I had a feeling. And there are several checks. There are several checks that you can do while doing this problem that let you know if you forgot to do one step here and there, right? So minus what f of x is, and that is just right here, 4x minus x squared over h. So this does take a lot of time, and it's very algebra intensive. There's a lot of adding and subtracting polynomials. It's kind of annoying, but if we follow the proper steps, which I would say first is to compute f of x plus h. Then we input everything to the formula. We simplify, and then we're going to do these two checks that I'm going to go over. We're going to be good. So now we're just going to simplify everything. We're going to have 4x plus 4h minus x squared minus 2xh minus h squared. And now we're going to distribute this negative in here and in here. So the first one is going to give me minus 4x plus x squared. We have negative times negative, so it's going to be plus x squared. My head is almost in the way, but not yet. And now we're going to do the first big simplification, right? So here we're going to cancel out like terms. So it's in blue. So we start off with this 4x, and we find a matching 4x. It's going to cancel. This 4h here. This 4h here just comes down. So the blue is kind of like a check that we're going to do. So this right here came down. This negative x squared is going to find a pair here of a positive x squared. So it's going to cancel. Then this minus 2h has nobody. So it's just going to be minus 2xh. And this negative h squared has nobody. So it's just going to come down. So here I'm going to do what I like to call the h check. So we're going to write that somewhere. Let's write that here. The h check. And by the h check, I mean that. Let me write that again because you can probably. The h check. The h check, what it means is that you're going to check that every term in your numerator has an h. We have an h here, we have an h here, and we have an h here. So every term has an h, so you're good to go. So most likely, you have done everything right up to now because all your terms have an h. So since they all have an h, we're going to do something that's very natural. We're going to factor out the h. And I'll tell you guys why now in a second. That leaves you with 4 minus 2x minus h over h still. Oh, it's assumed that we have the h in the bottom, right? So the reason why we are, I'm going to remove myself from there. The reason why we are factoring out this h, it is simply because the whole goal, the whole idea of this difference quotient, right, is to input everything, simplify, do our h check, factor out an h, and get rid of this h on the bottom. This h on the bottom, which is right here. The whole idea is we want to cancel out that h on the bottom. And the reason is because we have h approaching 0, so if we have an h on the bottom, we're going to get an undefined answer, and that is no good, right? So the moment we can get rid of this h, we can input 0, and we can finish. So now that we have factored out an h from here, and we have an h on the bottom, those two are going to cancel. Okay? So then our limit is going to stay as just 4 minus 2x minus h. Right? So what we've done here is that we have factored out the h and canceled it with the denominator. Okay? If you guys want to do this as two separate fractions, you guys can. But just know that what you did was you just simplified the top and took out an h. There's going to be way more practice on this so you guys can practice this. And the last step is, the last thing you do after you do your h check, you're going to compute the limit, which just means that you're going to input h equal to 0. You're going to input h equal to 0 into this h right here, the only h that we have left. So it's going to be 4 minus 2x minus 0, or just 4 minus 2x. So I'm going to remove myself. There is a much shorter way of getting this answer of 4 minus 2x, and you guys will learn it real soon. Just stay put. But for right now, this is the very long way, very long, annoying way of computing the instantaneous velocity, okay? Or a derivative, which you guys will learn all about this in a second. So what we're going to have here now is we don't actually have the instantaneous velocity. We actually don't have the instantaneous velocity at x equal to 1. What we have computed is the equation for the instantaneous velocity at any x, right? So here we're asking you just what is it at x equal to 1? So since our equation here is 4 minus 2x, right? Let's write that in green over here. 4 minus 2x is our equation for the instantaneous velocity, or the slope of the tangent. At x equal to 1, which is 4, we're just going to input 1. So 4 minus 2 times 1 is going to be 4 minus 2, or equal to 2, right? We get a positive number. So what this means is, if we go back to our graph here, we're going to do this in red, so it can stand out a little bit. When we go to 1, the instantaneous velocity, which is the slope of that line tangent to that point. So tangent means that it makes 90-degree angles. So we're going to say the line is tangent there. We're saying that the instantaneous velocity there, the slope of the tangent, is also equal to 2. So what you're saying actually is that at that instant, the slope of that line is equal to the slope of the secant as it goes from 0 to 2. So those two lines actually have the same slope in that instant, right? So I wanted to, since we already have the equation of any point, right? Of any point here, let's find out what the slope of, so this is at x equal to 1. Let's find out our x equal to x equal to 3. So it's going to be 4 minus 2 times 3, and that is going to give us 4 minus 6, or negative 2. So what is the meaning of negative 2? So as we go to 3, which is right here, let's do that in blue. So we're saying that, let's go, actually let's not do that in blue, so let's do that in red. So as we are going to 3, we're saying that at that instant, the line tangent, which is going to look like this, has a negative slope. And that makes sense. Because if you draw a line tangent to it, the line is actually decreasing, and the line tangent to it has a negative slope. Therefore, the slope of the tangent line at x equal to 3 is negative. Okay? So that is kind of where you can discuss about this. And let's do one last one so we can just make sure we understand all these different slopes. So at x equal to 2, we're going to have 4 minus 2 times 2, which is 4 minus 4. So we have 0. So what does it mean when the slope of the tangent line is 0? So let's go back to our graph. Let's do this in red. So as we go to 2, we're actually up here. We're going to say the slope of this line is 0. Well, that's a little off. The slope of this line is 0. So that means that right there we have reached the maximum of our graph, or we have a horizontal tangent line. So we'll discuss what this all means later on. I just kind of gave you guys the slope, the equation for the slope of the tangent line, and then we've talked about what it means when you have at different points, right? When instantaneous velocity at 1 it was positive, at 3 it was negative, and at 2 it was actually 0 because we had reached like the maximum. So right there over there is a 0. So I feel like here we actually talked a lot about instantaneous velocity. So now let's go into some examples of some different scenarios and what kind of problems these are. What kind of real life applications can we relate this to? So let's go ahead and do that, and I'll see you guys next time.